All right, so we are talking about volume of prisms and cylinders to start with. We've got ourselves, first let's talk about the definition of volume no matter what the shape is that we are planning to determine the volume of. The volume is the amount a container can hold, or known as the capacity of the container. Think of it like milk in a carton, oxygen in a tank, cereal, sand in a spherical container or something like that. We're going to use cubic units like centimeters cubed, feet cubed, meters cubed, etc. And we've got several different formulas on the formula sheet, so make sure you have page 76 out and available to you as we walk through this lesson or these lessons so that you can refer back to it. I'm going to do that right now. We have a couple of prisms that we talked about before. One of them we noted here is a prism. This guy particularly happens to be a triangular prism because his base is a triangle. And we also have our rectangular prism, which is over here. And this particular formula, notice the triangles, the rectangulars prism just says simply V is equal to length times width times height. Where the triangular prism, this guy over here, is saying that the volume is equal to big B times H. Okay, so two different concepts, but technically speaking, they really are the same. The SOL formula sheet was kind enough to give this to you separately because they really like for you to calculate volume of rectangular prisms. So that'll come up in an example here in a minute, but we're going to focus on our triangular prism in the example that I'm starting with. So go back to your notes. And it says to find the volume of a prism, we are multiplying the area of the base by the height of the prism, which we just looked at. So I'm going to take that formula from the formula sheet and I'm going to write that right over here. V is equal to big B, which is again the area of the base, and by the height of the prism. Let's make sure we understand what these dimensions really are. In the example you have here, we have a base that's a triangle. Now this guy, compared to the one on the formula sheet, is kind of laying on its side. So they're going to present them to you in different ways. And your goal is to determine where you have two shapes that are kind of on the top and the bottom or left and the right, depending on how they're presenting it. Our shape of our base here is a triangle. We also have the distance between the two bases, which is the height of the prism. Whatever that distance is between the two bases is considered the height of the prism. So let's make a couple of notations of what the known information is. What is known? We've got, according to our formula, H is the height of the prism. H is equal to 4. And the other known information is this 6 inches and this 8 inches. And it's referring to the dimensions of our triangle. We've got ourselves a triangle that is formed again for our base. And if I were to look at that triangle, these dimensions are not relating necessarily to the prism's formula, but I'm going to need them in order to calculate the area of the base. So let's get into that. The area of the base here, if the base is a triangle, let's go back to the formula sheet. Then I'm going to use what I did last block for the area of any triangle, which is going to be equal to 1/2 little b times little h. Now things get exciting because we have multiple little h's in our lives that we're going to need to apply correctly. I'm going to put a little p here next to that little h, and then I'm going to do the same thing over here so I know which height goes with which. And I'm going to recognize that since this is a triangle, I'm going to use big B would be equal to the area of a triangle, which according to my formula sheet is 1/2 little b times little h. And for the purposes of keeping this straight, I'm going to put a little t next to my h. So back to our known, the h of the triangle, h subscript t, is equal to 6. So I'm going to put a 6 here. And I've got myself the base of the triangle, and that is equal to 8. Sorry for all the colors. I'm just trying to make sure you kind of see what's happening. Whew. Okay, so fortunately we have our height of our prism. Now we're using the area of a triangle to determine what big B is. So we're going to substitute what we just wrote in our known area. Little b was 8, so we put an 8 here. And little h for the triangle is 6, so we put a 6 here. And we will get the fact that our big B is equal to 24. All right, so we have everything we need to go back to the volume formula. V is equal to big B times the height of the prism. Big B we determined above was 24. And the height of our prism we have here is equal to 4 because it was just given, right? It's given across the dimension, across those bases. So 24 times 4 will get me 96. And these are in inches, right? So I'm going to use inches cubed. And I have now determined the volume of my prism. As I mentioned, depending on what's given to you, if this prism was a rectangle, all right, I'm just grabbing this from the formula sheet, I would end up with these two dimensions multiplied by the height. And since my base of a rectangular prism is a rectangle, the area of that is length times width. So I'm already kind of doing the same thing here. Hopefully you can see that. That'll come up in an example below. All right, let's move over to the right-hand side, and we've got our cylinder. It says to find the volume of a cylinder, we're multiplying the area of the base, and this time they give you the area of the base, and they include that in the formula as pi r squared, because as you can see, we've got ourselves a circle here and a circle here for the bases of our cylinder. We've also got the height of our cylinder that we need for the formula, which they're calling little h again. And again, the height is the distance between the two bases. So I'm going to go to my formula sheet and grab that information. So back to the formula sheet. Got my cylinder down here, and I can see that the volume is fortunately given to me with that pi r squared already included. So I'm going to use that. I'm going to rewrite it on this note. V is equal to pi r squared times h. Oops. Let me make my h prettier. So we will, again, write the known information. What information did they give us? We've got the radius, which is helpful. We need it. The radius of the base is what we're using there. And you can see the dimension of that is 3 feet. We also need the height, which I highlighted in red. Just kind of overlay that again. And that's the distance between the two circles. So I'm going to show that here. Height is equal to 10. So for this problem, it really is a plug and play kind of thing. I'm going to rewrite what I know into the formula. V is equal to pi times r squared times h, which is 10. And when I do my math here, I get 282.7. But remember when we were talking about this the other day that we might have answers in terms of pi. So our goal would be to determine what that looks like. Now you can either divide this number, 282.7 by pi, or before you even go there, you can just multiply these two values together and bring that pi down. When you do that, you end up with 9 times 10, right, because 3 squared is 9, and this turns into 90 pi. So both of those answer choices would be correct. Okay, so we've got some problems down below. And what I'm going to have you guys do is work through these, and we have the answers posted around the room for the varying different volumes that we're going to be working on. You do have 2 more videos to look at. And just to make sure we understand ourselves, we've got ourselves in number 1, a prism, and the base is a triangle. And they fortunately have given us our dimensions that we need for the area of the triangle. A is equal to 1/2 little b times h. And you can see the little b is here, and the h for the triangle is there. And then the dimension between the two bases, right, where I have this other triangle on the other side. I'll highlight that in red as well. Is our 10. So we've got some known information that we will be able to use. But again, the same process is in play. Figure out the shape you have, determine the formula, write the formula down, and then substitute where you can. All right, go ahead and work through those problems. And when you're finished, I want you to get up and go check one of the answer keys to make sure that you got the right answer. If you have any questions about them, please raise your hand and we'll be glad to help you.